In this video, we will be looking at the graphs of polynomial functions. Specifically, we're going to look at the end behavior of the graph. What do I mean by the end behavior? I mean as x approaches infinity and as x approaches negative infinity. Meaning as x gets very large, what does the graph do? As x gets very negative, what does the graph do? Before I get into the examples, let's just look at some generic graphs. These first two pictures are of the graphs 4x to the fourth power and negative 4x to the fourth power. So what do I mean by the end behavior? The end behavior is this part, like what's happening on the ends. As x is getting bigger and bigger, what is y doing? Well, y is going up on both ends. Well, what happens in negative? Well, it's going down on both ends. Now keep in mind, we don't care at this point what's going on in the middle. We're just talking about the end behavior, something very easy. Now, here's 4x to the fourth again, but it has some other terms. Yes, the graph is not the same, but the end behavior is the same. It's going up on both ends. Same thing here. I put the negative, this is the leading term. All this other stuff does make the graph look different, but the end behavior is going down on both ends. This is the graph of y equals x cubed and y equals negative x cubed. Now this is definitely different. On the right-hand side, the graph is going up, but on the left-hand side, the graph is going down. So as x approaches positive infinity going that way, y goes up. But as x approaches negative infinity, y goes down. So let's look at what happens when we have negative x cubed. Well, definitely different end behavior. Now, y goes down on the right-hand side. So as x approaches positive infinity, y goes down or gets more negative. And it goes up on the left. So as x approaches negative infinity, y goes up. So what's the difference between these graphs and the other one? Well, the other ones were x to the fourth. This is x cubed, so odd, even. And again, our leading term x cubed, you can put all this other stuff, makes the graph look different, but the end behavior is exactly the same. End behavior is determined by that leading term, and that's what I need you to know. So can we write some just basic conclusions from what we've seen here? Well, I think we can say if we have an even exponent, then they either both go up or both go down. But if it's an odd, then we have one up, one down. So what do we mean by the end behavior? Again, we're just going to look at the leading term. And the leading term has the largest exponent. Okay, but we also want to consider the coefficient. So our leading term is 4x to the fourth. Okay, all of this part of the polynomial is going to affect the graph, but right now we just want to know the end behavior. Does it go up or down? That's it. Okay, because the exponent is even, then the end behavior will be the same. But now we need to look at the coefficient. The coefficient is positive. So that means they're both up. Same and up. So that means this graph, if we were to graph it with a graphing calculator, we would see it goes up on the right and the left. Right now, we don't know what's happening in the middle, and that's okay. We will get there. On this next example, our leading term, and I'm going to write that, leading term is negative 5x to the third power. Okay, so the first thing we want to look at that is the exponent is odd. So if the exponent is odd, odd means we're going to have different in behavior. So how do we know how different? We're going to look at the coefficient, and it's negative 5. Okay, because it is negative and we know it's different, we know it's going to go up and down, but which way? It's going to go up on the left and down on the right. And you're going, well, yes, I could just memorize it, but how could you figure that out? Easily. Let's just look at this part of the polynomial. Okay, if you put in some positive values, you're going to get some negative numbers. So when x is 2, y is like negative 40. So that's obviously going down on the right. But if you put in, say, negative 2 or even negative 1, this is going to be negative times negative, which is positive, and that's why it's going to go up. So again, we don't know what's happening in the middle of the graph, but we will soon enough. Now this next example, the leading coefficient is not apparent. Do I want you to multiply all that out? No, you can, but that's really inefficient. Let's look at this. We know it's just the leading term, so we're going to have that coefficient. And then we're going to take the leading term here, so we're going to have 5x all squared, and we're going to have x all squared. That's going to be our leading term. So we're going to have negative 3 times 25x squared times x squared. So that's negative 75x to the fourth. And that is your leading term. So again, we look at the exponent. It's even. So that means it's the same in behavior. But our coefficient is negative. So same in behavior, negative means it goes down on both sides. And again, you can memorize it, or you could just use your leading term as your function and plug in a positive value and say, oh yeah, that's negative 75. And you could plug in a negative value, and you're still going to get negative 75. And that's why it goes down on both ends. Going to look at one last example. So again, the leading term is not apparent. So we take the leading term in each parenthesis part, and we're going to have x squared times x to the first power. So that is x cubed. So that is our leading term. We have an odd exponent, so that means they're different in behavior. And my coefficient is positive. Okay, so how do I know? Well, again, let's just look at this part and plug in, say, a positive 1. So that's 1 cubed, which is 1. If I plug in 2, 2 cubed, which is 8. If I plug in any positive number, I'm getting a positive number. So as x gets bigger, y is getting positive. So it goes up on the right. But if I do some negative values, negative 1 cubed or negative 2 cubed, I'm going to get negative 1, negative 8, and it goes down on the left side. Okay, so odd and positive, up on the right, down on the left. So you could either draw me a picture or you could just write those words. Up on the right, down on the left. And that's all I need to know. So in summary, if the leading coefficient has an even power, then the end behavior is same, both up or both down. If the leading term has an odd power, then end behavior will be opposites, one up and one down. And the way you determine whether it's up or down would be the coefficient sign, whether it's positive or negative.